Hi everyone, this is going to be a partial key to your structural formulas, Lewis dot structure practice. So I'm going to do the even numbered problems for you. We'll start with number 2. So NF3, first need to think, okay, what needs to be in the middle here? Nitrogen can make 3 bonds, and fluorines can each make 1 bond, so we want that nitrogen in the middle. And then we can put 3 fluorines kind of around it. Now, valence electrons, each fluorine has 7, so I'll put those in. And nitrogen has 5, so 1, 2, 3, 4, 5. Okay, so now I've got to sort of attach on all the fluorines by making pairs of electrons. Make this a little smaller. So I can pair these 2 electrons, these 2 electrons, and these 2 electrons, and then sort of put it all together. I'll just do it down here, so I'll end up with that. Okay, and if I count everything up, I should find that all of those atoms have 8 electrons, which is what they want. So I am good to erase these shared electron pairs and replace them with a bond. So there is my finished formula. I can double check that I did everything right. Everything's got 8 electrons. Nitrogen started with 5 electrons. The fluorines each started with 7, and there were 3 of them. 21. So I should have 26 total electrons in this thing. And if I count them, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26. I do indeed still have 26 electrons. So that's good. For number 4, again, carbon makes 4 bonds, and chlorines only make 1 bond as their halogens, so carbon needs to go in the middle. Chlorines all around the outside. This one's going to end up pretty simple. You're just going to end up with this. There we go. So that's what you should end up with for that one. Okay, so the ones on this page are a little more complicated. We have CO2. Carbon makes 4 bonds, oxygen makes 2 bonds, so the carbon goes in the middle. Usually if we have carbon, that's going to be in the middle. So I'll put my C and my O's. Okay, then carbon has, I'll put valence electrons down here, 4 valence electrons, so 1, 2, 3, 4. And each oxygen has 6 valence electrons, 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. And there's 2 oxygens, so 12 total valence electrons there, so I want to end up with 16 total valence electrons in my structure when I'm done. So first thing I need to do is attach those oxygens on, get a pair of electrons, so there's a pair, doesn't matter which ones I pick because I can move them around. And I'll end up with this. Okay, and now I check my structure. Does everything have the correct number of valence electrons? Well, oxygen right now has 1, 2, 3, 4, 5, 6, 7. This carbon has 1, 2, 3, 4, 5, 6. And this other oxygen has 7. So this is not done. I, in fact, need to take another pair of electrons to finish this because right now I don't have enough electrons for each thing. So I'm going to go ahead and take these two and move them up there. So rather than redrawing this all again, I'm just going to erase that and then move those electrons. So we'll put them right there. Okay, let's count my numbers of electrons again. Now this oxygen has 8. That's good. That's what I want. This carbon now has 1, 2, 3, 4, 5, 6, 7. And this oxygen still has 7. Okay, so one oxygen's good, but I'm still not done because the carbon and the other oxygen still have 7. So I need to move another pair of electrons. So let's say I take these two. I'm going to put them down there. And then just erase this. Okay, let's count again. That oxygen still has 8, this carbon now has 8, and this oxygen now has 8. Alright, good. So now everything has 8 valence electrons, like the octet rule, like it wants. I should double check that I still have 16 electrons in here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Good, I still have 16. Didn't gain any or lose any. So I'm just going to turn these shared pairs of electrons into bonds, and since each of those was sharing 2 pairs of electrons, these are going to be double bonds. So I do 2 lines for a double bond, and there's my finished structure there. Last one I'm going to show you is this sort of challenge problem down here, number 8. So this one is a little more complicated, and we'll see why, but I've got a carbon and oxygens. Carbon can make 4 bonds, so I'm going to put carbon in the middle. I'm just going to do it up higher on the page so that it's easier to see. And then I've got 3 oxygens. So carbon has 4 valence electrons. Oxygens each have 6. So I'll put those in. And then I've also got, this is one of those polyatomic ions. It has a 2- charge, so that means there are actually 2 more electrons in this structure. Not 2 electrons for every oxygen, just total 2 more electrons in here. It doesn't actually matter where I put them right now. I can move them around at will because electrons that are in this structure sort of belong to this structure. But let's just put them on the central carbon for now, and we'll see if we need to move them later. I'm going to tally my total electrons so I know at the end if I've got the right number. So 4 for the carbon, 6 for each oxygen, times 3 is 18, and then 2 more. So if I add all of those together, I get 24 electrons I should have at the end. Since this is a little more complicated one, it's going to be important to check that and make sure I really do have 24 electrons at the end. Alright, so let's make some pairs. Bond these oxygens onto the carbon. Let's take those, why not? And then I'm going to redraw this. Let's see. I'm going to just put, I have 1, 2, 3 electrons left on this carbon. I'm going to kind of put them on the bottom just to get them out of the way so I know that those aren't shared electrons. And then I'll put the rest of the electrons that were on these oxygens back on here. Alright, so here's what I've got so far. I can count my electrons again to make sure, but I should still have 24 electrons in there. Now, how many electrons does each thing have? This oxygen has 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 6, 7. These are all going to have 7. And the carbon has 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. Well, none of those numbers are 8, so I know this isn't a completed structure. Carbon actually kind of has too many electrons right now, so we'll have to deal with that. But for now, the oxygens don't have enough, so I am going to go ahead and make another bond, and rather than doing all of them double bonds, I'm just going to do one at a time. I'm going to be cautious. We might not need everything to have a double bond, so let's just take this one. And we'll pair those electrons and then move them in. I'm just going to erase those. Put them right there. And let's count again. Now this oxygen does have 8 electrons. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Carbon is up to 10 now, and those oxygens still have 7. So this is the part where it might be a little tricky to figure out, but if you look at the oxygens each need 1 more electron, right? And the carbon has 2 electrons too many. So I don't actually need to make any more pairs. I just need to move these electrons off of carbon and onto these oxygens to make everything even out. Because if I take 2 away from carbon, carbon's going to have 8. If I give 1 to each oxygen, the oxygens are going to have 8. So I'm just going to erase all of that. And go ahead and move those electrons, 1 to each oxygen. So put 1 there, put 1 there, and now everything has 8. I'm going to double check. I wanted 24 electrons. Let's see, let's highlight them in green just to make sure we've moved a lot of stuff around. So we need to make sure we didn't lose anything or gain anything. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. All right, we did it. So the last step again is to erase these shared electrons and turn them into bonds. Like so. Now you might be wondering, like, could I have actually, when I arranged it, put the double bond here instead of here? You know, could I have made that the double bond? And yeah, you could have. You could have also put it on the other oxygen. It didn't really matter which one ended up with the double bond, but you did need one of them to have a double bond. So yeah, I know this last one was more difficult than the other ones. That's why it had a star by it, but hopefully that helped.